let's move on now. The second subtopic in our acquisition workflow is the acquire configuration. This will help users configure microscope and software for acquiring SRS image stacks. It will also empirically determine tissue thickness. Select which contours we wish to be imaged if we've delineated more than one contour per section. Set probe dimensions and specify SRS grid dimensions. Step 4, or set acquired magnification, directs the user to move to the objective lens which will be used for acquisition. As we've mentioned before, it is critical to use a high-powered objective with a high numerical aperture. For this demonstration, I will be acquiring with a 100x foil objective, which I'm going to move to now.
本日はご来店いただき誠にありがとうございます。お住まいに関するお悩み事はございませんか？安心で快適な暮らしをサポートする生活提案型山田の
Clicking anywhere in the macro view with the left button will move the stage to that location. This can be useful if tracing edges need to be aligned with anatomy. To shift the region of interest, right-click the end-joystick mode. Select the Align Tracing button. Click anywhere in the contour, and then click the location on the tissue where that position of the contour should be. One of the benefits of having semi-automated hardware is that it is possible to have hardware process here in software. For example, here, the software process to finish adding oil or to change immersion oil before continuing. I'm now adding a bit of oil to my slide and returning the stage to its working position. I use my video histogram to get an appropriate pixel citation, and then find my tissue by focusing. The software has kept track of the fact that I added immersion oil for my 53x objective, and so when moving to my 100x objective, no longer prompts me to do so. Fantastic. So you can see here that the software has detected that we are on using the 100x objective lens and has selected the appropriate lens file from the software. If your particular hardware does not have this type of communication ability, it is important to always manually drop down and select the appropriate lens. I'm going to go ahead and close my expectation lens shutter once again to preserve my tissue staining. After we have set our microscope for acquisition power, we can hit next step. This step, or region selection, allows the user to select multiple regions if available to scan and acquire image stacks from. As we have selected only one region of interest, it is selected here. You can tell it is selected by the fact that it's bounded by this white box. If you add multiple regions, they would appear in this work area as well. It's possible to simply select all regions to have them all selected, or unselect all regions conversely. Once you've selected the regions of interest that you are interested in acquiring from, you may hit next step. This step, step 6, counting frame settings, prompts the user to enter their predetermined counting frame size. For this demonstration, we shall use the dimension of 15 by 15 microns. The actual dimensions that you will be using for your analysis must be determined empirically, and there is no standard value that I can offer at this time. Hovering the mouse over the counting frame, turn the cursor into a four-headed arrow. Clicking and dragging sets the position of the counting frame into a location where it will be found during analysis. It's also possible to use the mouse to move each side of the counting frame wall. As I mentioned earlier, we're going to use a 15 by 15 micron box. Once the user has entered the counting frame dimensions in X and Y, we can hit next step. Step 7, or SRS grid layout settings, directs the user to enter the predetermined systematic dimensions for SRS layout. We predetermined, for this demonstration, a layout of 1100 by 1800 would be sufficient. Alternatively, a user can use the approximate site option to enter the approximate number of sites that they wish to have in this contour. So for example, if a user enters 6 and press estimate grid size, then the software will calculate an approximate grid size for that particular number of approximate grid size. We're going to stick with our predetermined values. Step 8, for image stack settings, directs the user to enter values related to the probe and the tissue acquisition. The first box here, labeled collect the following set of images, allows the user to collect images for either the mounted thickness, the probe and guard zone, or the probe only. The default option is for the entire mounted thickness. Some users may find it useful to gather the entire thickness of the tissue, while others will only want the probe and guard zone only. It is possible to collect additional images above your tissue by entering the desired value there, as well as below. And now we're ready to enter our image stack height information. The first step here is to empirically determine mounted thickness. For this, I will need to have a live view. So I will once again use my device command sequences to get my expectation light shutter open and get my DAVI cube in place. Pressing the mounted thickness set button brings up an ancillary menu that we can use to empirically determine our tissue thickness. The way I want to do this is to focus at the top of my tissue. I will use my finger to make sure that I'm moving appropriately. And my favorite technique is to focus above the tissue until everything is out of focus, and then slowly come down until only a few objects are in focus. In my estimation, this is that location. I will then press set top of section. I will now want to focus down, past the bottom of my tissue, and focus up slowly until only a few objects are in focus. In my estimation, this is at the position. I will now press set bottom of section. When I press add measurements to list, a tissue height is calculated. Having an average mounted thickness measurement that reflects the reality of your tissue is critical to your stereological analyses. We recommend measuring thickness at various locations. One easy way to do this is to click anywhere inside of your contour in the macro view. You can then go to a location distant from the one you just measured and repeat the operation. Software begins to calculate the average mounted thickness and export that over to the mounted thickness in the Enter Image Stack Height information box. The number of locations that you choose to measure thickness will vary depending on the size and area of your contour. The larger your contour is, the more locations you are going to want. If you believe that you generated a measurement in error and are confident that it does not truly reflect the tissue thickness at that region, you can select it here and delete it. Then you can repeat the measurement or move on to another location to measure there. After I'm done measuring in various locations, I will once again close my citation filter and now enter my probe values. We have predetermined that for this demonstration, a top guard zone of 3 microns and a probe height of 11 microns is suitable. The final option in step 8 is to enter a value for the distance between images. Depending on your hardware, the minimum value that you will enter here will vary. We recommend looking at your hardware specifications as well as the memory capabilities of your computer before making the decision of a step size. Other important considerations are the sizes of the objects that you wish to observe and count stereologically. We will proceed with a measurement of 1 micron step size. The final step, or step 9, directs the user to choose a location for saving the data and image files. So we have already entered a path here for a folder on my desktop. The next option is to give each of the images in your series a base. This makes it easier to go through and find a specific image, even an image that is part of the Z-Stack later on. The images generated by the SRS Image Stack Acquire workflow will be titled whatever you name here, for example, webinar, followed by a series of numbers. In this way, each of the images of your Z-Stacks will have a unique name and will be able, making it easier to identify and find it at a later time. If the user wishes to engage camera pinning, they may do so here. We're going to go ahead and take images with our camera's highest resolution. The user can also pick the format to save the files in, specifically their image files. The options here are JPEG 2000 files or TIFF files. We at NDF strongly recommend using JPEG 2000. Finally, I will enter a file name for my data. At this point, I'd now like you to post your questions regarding selecting the region to the image, entering counting frame and SRS grid dimensions, image stack settings, or image file types and output locations. Jeffrey asks, what is the exhaustive grid option in the layout step? Jeffrey, for some highly infrequent events, such as, for example, co-labeling of VRDU and, let's say, NUN, for these types of events, it may be impractical to do a systematic and random image stack acquisition within one contour. Now, even if you are using serial sections that don't come one after the other, let's say that you were using tissue where your serial sections were every 6th section, you may want to exhaustively sample all of the VRDU sync cells in each of your sections. This essentially means that you want to count all the VRDU positive labeled cells in this one region of interest. To that end, the exhaustive grid option makes it such that the entire area of your entire contour region of interest is image. In the end, when you do your analyses, you will be counting all of the low-frequency events in each of your sections. So whereas it sounds like you may not be doing actual data estimation because you're counting every object, it's important to remember that you're counting every object on only those tissue sections which you are sampling. So now I have a question about hardware, specifically the type of hard drives that should be used. We recommend that for the acquisition process, you write directly to an external hard drive. We've had some users write their data to either network drives or external USB drives. What we've encountered is that there's a potential for data buffer interrupts, or there may be some problem in writing to an external hard drive. This may result in some technical problems. Our recommendation is to always acquire your tissue and write the files directly to a local internal hard drive. Great, thank you all for your questions. Let's move on now to our final submenu, which is the Acquire submenu. In the Acquire submenu, users will be prompted to specify pre-focusing locations, pre-focus to the top of tissue sections, save imaging configurations for future use, and also optimize camera settings for multi-channel fluorescent acquisitions. I will now go on to the next step, or step 10. In order to obtain SRS image stacks of your tissue from the top to the bottom of the Z position, it is important to indicate to the software the location in space of the top of your tissue. We recommend measuring at every acquisition site. In this way, you will have the most information about tissue top locations and have a greater chance of scanning and acquiring Z-stack images from the entirety of the Z axis. Alternatively, interactive site selection is possible. In interactive site selection, the user selects locations along which to go through and measure tissue tops. By hitting the top of the section button, the software will then take me to these locations where I will focus at the top of the tissue. A third option is to simply set the current Z position as the top of the tissue section. Using this option means that regardless of the true top Z position of your tissue, SRS image stack acquisition will always begin at whatever the Z position is now. I'm going to select to identify the section top at every site. Once again, we use the technique of focusing up above the tissue and then coming down to focus along the top. Once the top of the tissue has been identified in all the predetermined locations, the user may hit next step. At this time, you may wish to save the sampling configurations which you've just entered. In doing so, expedites the process of SRS image stack acquisition in the future by simply loading the grid size, counting frame, and various other values for future use. I will demonstrate how to save this. There, we successfully saved these settings. The next time that I need to acquire image stacks from another subject of this group, whether it be control or experimental, I can simply use these settings by loading them up, as you saw in step 1. Step 12 is the final step, and is also known as the image acquire step. The acquisition list selects all the regions or contours which you have delineated that are going to have image stacks sampled from them. As we have only delineated one contour, only one contour is listed and selected. Multiple contours would be listed here. The acquisition box allows the user to insert a delay time before acquiring each image. While we will not use this today, some users may find it helpful to have a delay between each image. One potential reason for having such is that stage movement may not become dampened before the next image is acquired. This may lead to blurry or out-of-focus images. If users find that this is the case, adding a delay time in between the acquisition of each image may solve the problem. As we are performing a multi-channel acquisition, I will select the multi-channel acquire box. I will then select multi-channel setup and pick the channel that I want to acquire. In the acquire setup box, I can define whether I would like red, green, and blue channels acquired, or any combination thereof. This tissue has both GFP and GAPI staining, and thus we will pick those two. Now, we must optimize our camera settings for each channel. To do that, we will use the multi-channel control, the camera settings box, as well as the video histogram. Our goal will be to use the exposure to achieve as broad a histogram as possible. I'll begin with the GAPI channel. First, I select GAPI under multi-channel control. I'm going to use my macro view to move to a representative location of tissue. I will then focus down. You will notice that as I move the exposure settings, the shape of the histogram changes. Optimal images will be achieved when the histogram is at its broadest along the x-axis. It's possible for users to adjust the black and white points, as well as the gamma shift for this acquisition. The default button will bring to default values and optimize direct to software to pick what it believes to be an optimal value.